Hi everyone, and welcome to your video lesson on domain and range. Domain and range of functions. Now, let's remind ourselves, because I did define this in the last lesson. Domain is where x lives, okay? So domain is the x's of your function. And range is where y lives. It's the y values of your function. And the way I like to notate domain and range is pretty simple and obvious. I put capital D with a colon and then capital R with a colon when I'm ready to state what the domain and range of a function is. Okay, so let's look at number one. When you're given a list of ordered pairs, the domain will simply be all the x values listed out, and the range will simply be all the y values listed out. This is probably the easiest type of domain and range to do. So let's look at the example that goes with it. It says, given the set of ordered pairs, and then you have this long list here. Let's see, how many do we actually have? 1, 2, 3, 4, and 5. We have 5 ordered pairs. It says, find the domain and range. So this is how simple it really is. You put capital D for domain, and you list out the x's. Now, some people prefer to do it in order from lowest to highest. I happen to be one of those people. So what I like to do is I'll circle my x's first. So here's a 9, a 7, a 4, -10, and a -2. Okay, so from least to greatest, I'm going to start with -10, then -2, then 4, and 7, and finish with 9. So there's my domain. These are all my x's. And then I do the same exact thing for range. Now, I'm having trouble concentrating on these y's, so let me highlight the y's. I've got a 2, a -3, a -6, a 4, and a -7. So from least to greatest, I'm going to go with -7, -6, -3, 2, and 4. So how easy is that? Domain, list out your x's. Range, list out your y's. Okay, let's look at number 2. The domain and range of a line with arrows on both ends. So this is what we've been studying for a few weeks now. Our lines where we draw our line and put the arrows on. That domain and range will always be the same unless the line is horizontal or vertical. So if you have one of your special cases, we'll have to look at that on the next page. But if it's just a slanted line, then your domain and range, I've got it written out here for you. The domain and the range is simply, and you can kind of, I'm going to get rid of this part. You can kind of scratch this part out. I don't think we really need that. That's really fancy notation, and I think I changed my mind about using that. I think we're just going to do domain and range, and then look what it is. Your x values are situated between -infinity and +infinity. Remember this fancy notation? X is between negative and positive infinity, and y is between negative and positive infinity. Okay, and you might be thinking, that's weird. What does that really mean? Well, I'm going to show you in the example here. So example 2 says, find the domain and range of y equals x minus 3. Okay, so let me highlight over that. Domain and range of this equation. Well, first I'm going to say, if I asked you, give me a number that you can plug in for x. Just think of a number that you can plug in for x. You might say, all right, I'll plug in 10, and 10 minus 3 is 7. Or I'll plug in 100, and 100 minus 3 is 97. Or I'm going to plug in 0, and 0 minus 3 is -3. The truth is, I could ask anybody, what do you want to plug in for x? And I'd get all kinds of answers. Because the truth is, I can plug any number in for x. It's legit. Negatives, positives, 0. I can put a fraction in, a decimal, as long as when I subtract 3 from it, I get my y. So that is one reason why the domain x is anything. And when you say from negative infinity to positive infinity and everything in between, you're saying I can plug anything in for x. And I'll tell you what, the end result is you can get anything out for y. And that's why y is what it is. That's more of just intuitive, analytical looking at that. Now, if I graph it, so if I were to graph this, what would it look like visually? Well, I'd start my line, let me kind of change colors here. I would start my line at my negative 3 y-intercept, 1, 2, 3. And I have a slope of 1. So I'm going to just kind of kick out here a little bit, draw these little tick marks. So my slope is rise 1, run 1. Rise and run, rise and run. So you can see that when you connect these dots, this line stretches far beyond my paper constraints here, but this line just goes on and on and on and on and on. It follows the entire x-axis and the entire y-axis. So it's just going to keep growing left to right and growing bottom to top. And so your x's and your y's are every real number between negative and positive infinity. So you're just going to have to try to memorize that, but I also hope you understand it. Okay, flip the page. Number 3. Now we'll talk about the horizontal and the vertical because they are a little different. So number 3 says the domain and range of a horizontal line will be a little different than slanted lines. And again, I'm going to cross out this part right here. You can just kind of scratch that out. Okay, so let's check it out. So the domain, interestingly enough, stays x between negative and positive infinity. But the range is just whatever the y value is. So let's look at the example. Find the domain and range of the horizontal line, y equals 4. So I want to do this visually. So we're going to graph the horizontal line y equals 4. So let's draw an x and y axis. Here's x, here's y. And I'm going to go up to y equals 4. And I'm going to draw a horizontal line there. Now, do you see how the x, let's look at the x's. Do you see how we go infinitely far to the left and infinitely far to the right? So our x's are everywhere from negative infinity to positive infinity. That's why this is true. However, let's look at the y's. The y's don't go anywhere. They're stuck right here at 4. So no matter where I go, I mean, I could go to this point right here, this point right here, here, over to the right. No matter where I go, all of these y values, like if I was doing ordered pairs, the y would always be stuck at 4. So we've got a little different situation here. So if I was doing the domain and range of example 3, I would say that the domain is everywhere, negative to positive infinity, but the range is just 4, y equals 4. So that's how you do that. Now it's sort of the exact opposite for the vertical line. The domain and range of a vertical line is going to look like this. Again, I'm scratching that fancy stuff out. So the domain will be whatever the x value is, and the range is going to be the negative to positive infinity. So let's look at example 4. Find the domain and range of the vertical line, x equals negative 5. So draw this out. Here's x, here's y. Now x equals negative 5. We know where that is. We go on the x-axis to negative 5. And we draw vertical line. now you can see that in terms of your domain, the x's don't go anywhere. If you look right and you look left, you don't see anything. The x's are fixed at -5, no matter where you go on this line. Anywhere, the x is -5, the x is -5, the x is -5. But the range, which are the y values, that just spreads out everywhere, bottom to top. It goes down and up. So my y's are definitely situated between negative and positive infinity. Okay? Last page. Last page. Number 5. The domain and range of a line segment will be completely different than a line with arrows on both ends. So if you're doing the domain and range of a line segment, which you're going to see below here, then your domain, your x will be trapped between the lowest x and the highest x, and your range will be trapped between the lowest y and the highest y. So let's take a look at this example. Find the domain and range of this line segment from A to B. What I like to do personally when it's a segment with no arrows, I like to write the coordinates first of the endpoints. So let's do A. A is situated at -3, -4. -3, -4. And B is situated at 4, 3. Okay. Then what I like to do from there is come off to the side, and I like to set up my domain D, range R, and I even like to put my sort of my skeleton down. For domain, I know domain is X, range is Y, and I like to put my symbols pointing left. We learned this in the last unit, or the last unit. We learned about this notation, lowest to highest. X is bigger than the lowest but less than the highest, and same for Y. Okay, so let's look at our X's first. X's. So this is an X, and this is an X. Well, which one's lower? I think this one, -3. So I'm going to put the -3 over here and the 4 over here. And all that's saying, guys, is that this little line segment lies between here and here on the x-axis. Okay? This way. Horizontally, -3 to 4. And the range, what are my y values? Well, -4 and 3. Lowest is -4, highest is 3. And that is just trapping me on the y-axis from here to here. And what ends up happening, if you think about it, you kind of just got yourself boxed in here. If I draw some dashed lines here, can kind of see this. X to X, Y to Y. We just put it in a fancy notation. Last but not least for this video, domain and range in the real world. Let's talk about it. A Little League baseball team is planning a trip to an amusement park. They are taking a bus which holds 32 people. It will cost $25 for parking, and tickets to enter the park are $22.50 per person. The equation that models this situation is, and look at this great function notation, you know, like f of x, g of x? This is C of n. C of n equals 22.5n plus 25, where C represents the cost for the group to go to the park, and n represents the number of people who go on the trip. So what's really cool about this is, like, look at how this works. So C is the cost. The cost in terms of the number of people going, C of n. Cost in terms of the number of people going. Now watch. So you take 22.5 times the number of people going, so that's going to be your tickets, plus parking. So pretty simple. Now they're asking me, what is a reasonable domain and range for this situation? Okay, so let's think about it. My domain, now this is going to be a little bit different. You got to think about x and y. Really, what's the x in this scenario? The X is like this N. So domain is the N, which is the number of people. So we have to ask ourselves, what is a reasonable number of people that could go on this trip? And you can pause the video to think about that. And when you come back, I'm hoping that you thought the bus only holds 32 people. So no more than 32 people can go on this trip, okay? So I'm thinking that a reasonable number of people to take on the trip would be between 0 and 32 people. You know, it'd be great to fill up the bus, but anything in between 0 and 32 would work. So I'm going to write my domain like this. I'm going to put N in the middle, number of people, and I know that I want to stay under or equal to 32. I can equal 32. The bus holds 32 people. But I want N to be greater than 0. Notice, I'm not putting an equal to on this one because if I don't have anybody, if I have exactly 0 people, the trip wouldn't run, and to me, that's not reasonable. So a reasonable domain is like 1 to 32 people. So I'm going to put it back here. And I also want to say, I'm going to put a little disclaimer back here. N is an integer. Why do I say that? Well, you can't have half of a person. So I'm saying my integers between 0 and 32. So 1, 2, 3, 4, like that. Okay? And you might even say, well, Ms. Callahan, that's not reasonable because this should be a 1, not a 0, because you want at least 2 people on the trip. What, is somebody going to go by themselves? Well, we don't know. Maybe they like to be alone. So either way, 0 or 1 and greater than that would be great. Okay. So then what's a reasonable range? Now remember, the Y value in this situation is C, the cost of the trip. The cost of the trip. So what I'm going to have to do to figure out the cost at N people, I'm going to have to plug in these endpoints, okay? So I'm going to have to plug in my first integer that's bigger than 0, which is 1. So if one person goes on the trip, the cost for one person to go, C of 1, is equal to 22.5 times 1 plus 25. So the cost for one person to go on this trip is $47.50. Do I have that right? If I add $25 to 22.50, yep, $47.50. So my cost is going to be between $47.50, that's the cost for one person to go, and up to, we don't want it to go over what the cost would be at 32 people, so let's do cost at 32 people on the trip. That would be 22.5 times 32 plus parking at $25. And so the cost for 32 people to go, let me get my calculator here. Can't do that one in my head. I'm going to do 22.5 times 32 people. That's tickets plus parking, $745. So $745. And this is money. So if my domain is between 0 and 32 people, or I should say 1, you know what? Maybe it would be easier just to do this one like this. Let me scratch that out. Sometimes I change my mind. Why don't we just put a 1 here and an equal to sign? That might be easier. My number of people should be between 1 and 32 inclusive. And then that really shows between $47.50 and $745. Domain and range in the real world. All right, thanks for watching.